of diffusion. It states that the rate of diffusion of a gas is inversely proportional to the square root of its density. Rate, of which we know is R, is directly proportional to the square root of its density. That is rate. And of which, when you remove the sign of proportionality, something like this happens. You now have R equals 1 over square root of what? Density. And I know that rate is the reciprocal of time. That is, rate is the reciprocal of time in seconds. We are trying to derive all the formulas used in this calculation. Don't forget that this is the mathematical relationship of the rate law or the Graham law of diffusion. Rate of diffusion of a gas is inversely proportional to the square root of its density. So, assuming we are comparing the rate of diffusion of two gases, that is rate of gas A, which is 1 over TA, and rate of diffusion of gas B, which is 1 over TB. Don't forget, we are comparing the rate of diffusion of two gases A and B. So it then means that RA over RB equals TB over TA. It is very simple, but let me show you. Remember, rate of A is this and this, rate of B is this and this. So, rate of A divided by rate of B equals 1 over TA divided by 1 over TB. Don't forget, this is rate of gas A is reciprocal of time A, rate of gas B reciprocal of time B. So, if you are now checking it all over, mathematically, it then means that 1 over TA multiplied by TB over 1. Don't forget, you are now bringing this one up. So that is why it is rate A over rate B equals TB over TA. Because 1 times TB is TB. So don't forget this formula. Don't forget this formula. And also, I know that rate is proportional to relative molecular mass. Rate is proportional to relative molecular mass. That is to say that rate of gas A, remember we are still comparing the rate of two gases A and B. You can substitute density for time, substitute density with what? Relative molecular mass. Since rate is proportional to relative molecular mass. So if that is the case, you now see, remember, square root of its density. You now see rate as this, MA divided by MB. Now let's compare the three formulas we have been able to derive now. Rate of gas A, rate of gas B equals TB over TA, which is the same thing as square root of MA over M what? B. If you know this formula very well, you will go far. There's no problem you cannot solve in rate of diffusion. And don't forget that rate of gas diffused. I'm not trying to exhaust all the formulas we use in calculating all these things. The rate of diffusion of gas is equal to volume of that gas diffused. Okay, volume diffused over time. Thank you. So all these things are the formulas we use in calculating rate. Volume diffused over time. So just check the formulas once again. We will go over to the calculation proper.